Okay, this is the beginning of Unit 7, Week 5, Lecture 9. And we're still talking about water as a solvent. And what we're going to start learning now is that water is special because it is extremely polar. And so in this lecture, we're going to start learning about what does that mean, extremely polar, and how can you determine if a molecule is polar or not. So that's the point of this particular lecture here, Lecture 9. So if we're going to talk about whether or not a molecule is polar or not, we better remind ourselves of different types of compounds that we talked about last semester. And we know that there's basically two types of compounds, ionic compounds and covalent compounds. And remember that ionic compounds are made from metals and nonmetals plus nonmetals. Whereas covalent compounds you can identify because it's a nonmetal bound to a nonmetal. Okay. The other thing you know that when an ionic compound is formed between a metal and a nonmetal, you now understand that there's been some electron transfer that has occurred. The electron has been transferred from the valence shell of the metal to the valence shell of the nonmetal. So we end up with cations and anions, positively charged species and negatively charged species when we form these ionic compounds. And those compounds don't exist as discrete molecules. We don't call them molecules. Ionic compounds, sometimes we call them salts, or we call them formula units because they exist in these crystals in arrays, three-dimensional arrays of positive charge surrounded by negative charge, positive charge surrounded by negative charge. So they're not molecules. All right. Whereas the covalent compounds, the nonmetal plus the nonmetal, in this case what's happened when atoms have approached each other to form a covalent compound, the electrons have been shared. The valence electrons are being shared between the various atoms in the molecule. Typically they're shared such that they satisfy the octet. Okay, so they're minimizing the energy by coming together and being shared. The electrons reside between the atoms, and they do form discrete molecules. Okay, so molecules. So when we talk about polar molecules, we're talking about covalent compounds. All right, polar or nonpolar we're talking about covalent compounds because we're talking about molecules. Now, within molecules and within formula units, we have bonds. And you can have, in an ionic compound, you're going to have ionic bond, and in a covalent compound, you're going to have a covalent bond. So as it turns out, all bonds can really be viewed as hybrids between purely ionic and purely covalent, except for those cases where they are purely ionic. But anyway, and purely covalent. So what are we talking about here? What am I talking about? So when two identical atoms are bound, it's purely covalent in this case. So this would be a pure covalent where the two atoms are identical. So that means that this blue sphere here is representing the electron cloud, and the two dots are representing the nuclei. And what they're showing here is that the electrons are shared equally between these two atoms, okay, purely covalent. When two different atoms are bound, one may have a greater attraction for the electrons. Okay, and in that case, that one that has the greater attraction, that atom that has a greater attraction, might carry a partial negative charge. Okay, in this case, this is a covalent bond between two atoms where the electrons are not equally shared. And the way we model that is with this electron cloud, showing that the electron cloud is bigger around the atom that has the greater attraction for the electrons. And we actually use this symbol. It's a little delta with a negative, so that this actually has what we would consider a partial negative charge, and the delta positive is a partial positive charge. So the electrons are not evenly distributed in this case. In this case, when the electrons are not equally distributed within the bond, it's called a polar covalent bond. Okay, and you can measure, there's different degrees of polar covalent bonds, and you measure it using a dipole moment. Okay, and that's just putting the molecule in an electric field and measuring its dipole moment within the electric field. So there are different degrees of polarity. And when one atom has a much stronger attraction to the electrons than the other, then the electron may be donated, yielding an ionic bond. So this is the case of the ionic. This is the pure covalent, and this is the case that's in between, and this is called the polar covalent bond. Okay, so polar, the word polar means has two poles, a negative pole and a positive pole, because the electrons are not equally distributed. So a polar covalent bond would fall in between the extreme of purely covalent and purely ionic. All right, so there's something, so the bonds then may have an unequal distribution of electrons.